Welcome back, guys. This is part 3 of the Chapter 13 AP Environmental Science lecture. Starting this video with geothermal. Geothermal energy is going to be heat that's stored in underground rocks and in the fluids in the Earth's mantle. Definitely, if you're in the right place, it's really has a great potential. But there aren't a ton of sites that would be suited for geothermal energy. Typically, So, sorry, give me just a second. All right, sorry about that. I had an issue with my PowerPoint freezing. Hopefully it doesn't happen again. So a geothermal heat pump system, like I said on the last slide, is really environmentally friendly. It's efficient, it's reliable, it doesn't cause a huge impact on the environment to install it. But again, there just are so few sites. It's hard to depend upon that being a broad system. There are also these things that we call hydrothermal reservoirs, and you can see we're extracting various steams and water. We have a lot of it here in the U.S. We have big hydrothermal reservoirs, but again, they're not everywhere. We can inject water into rock to produce steam if there's hot, dry rock, which we see some of. Let me show you the picture of one of these pumps. So I know it's really small and kind of hard to see, but this is our generator and our steam turbine. So that's what we've seen in every one of these alternative energy sources. This is an injection well, which is just like it was in fracking. We're adding water. Maybe we're adding steam, depending on the specifics of this individual site. As it comes down, as it enters this geothermal reservoir, we're going to get hot water and steam pumped up out of the production well, and that's going to move through this heat exchanger. The heat exchanger then is going to cause the turbine to turn and generate electricity that way. So the challenge is that's not a cheap thing to do. Drilling down and finding a hydrothermal reservoir is not cheap. There aren't a lot of sites. There is a little bit of noise pollution, and there is some carbon dioxide emission, particularly in the production stage when we're drilling. And you're kind of fracking, so you could cause micro earthquakes in some places. Our next renewable energy source is hydrogen. It's a clean energy source as long as it's produced without the use of fossil fuels. That should say without, but it does have a negative net energy. So we're spending more energy to make it currently than we harvest from hydrogen. So it's not a great source yet. It's one of those theoretical things that maybe someday down the road, once we get this system figured out, once we figure out some of the nanotech applications, it might really be productive, I guess is the word I'm looking for. Eliminates most of the air pollution problems, reduces threats of global warming and climate change and all that kind of stuff. But typically hydrogen is locked in water and organic compounds, and the CO2 levels are dependent on how we produce the hydrogen. If we make it from something like water, we're not going to create a lot of CO2, but if we are stripping the hydrogen off of organic molecules, we're going to make a lot of CO2. So because of that fact, we get a negative net energy, because sometimes we have to produce this hydrogen by burning biomass or by burning coal or something along those lines. So we need to find a way to harvest the energy stored in hydrogen from things like a water fuel cell, a hydrogen fuel cell that converts water, splits water into hydrogen and oxygen, and then recombines it later in the fuel cell. So how can we transition as a society? We've got to take baby steps. It's for sure going to require a mix of those renewable energy resources. I don't think it's practical for solar to power the world or wind to power the world. Yes, it could. It has the potential to, but it's also going to be really expensive, and there are going to be lots of environmental impacts in just transporting that energy from where it's generated to where it's used. So if we can have local grids that we produce the electricity locally, we use it close to where we produce it, we eliminate some of those issues. And we can use the things that work well for us. If we have a lot of wind, let's use wind. If we have a lot of sun, let's use solar. If we don't, let's use neither. Let's use something else. Let's find what works in our ecosystem and do that. I skipped including the environmental and health costs of energy resources in their market prices. That would be great, but I just don't envision that happening. Maybe I'm jaded against our political system. I just don't feel like those types of things are going to happen. Maybe they will, maybe they won't. Maybe we will start subsidizing our future instead of our past. Who knows? But general conclusions, like I said, the gradual shift to smaller and decentralized micropower systems, that's huge. Combination of increased energy efficiency and transition to renewable energy. I left that out in my last slide. I didn't talk about energy efficiency. Let's use it more efficiently. Let's stop wasting electricity with our cell phones just being plugged in at fully charged, or let's stop wasting energy through vampiring and things like that. But we are going to keep using fossil fuels. We're going to be doing that for a long time. Probably 50 or 100 years, we're going to have to keep using fossil fuels, and maybe even longer than that. Hopefully we can come up with some innovations that allow us to completely get off of carbon as an energy source. But that's going to take some time. So that's really the gist of Chapter 13. Be ready to talk about this on Monday.